So question 2 related to chemical energetics, paper 6. A student investigated the temperature change between anhydrous lithium chloride when it dissolved in water. In experiment 1, using a measuring cylinder, 30 cm cube of a distilled water is poured. So student used a measuring cylinder and he filled with 30 cm cube of a distilled water into a measuring cylinder, and then he poured into a large beaker of which can maximum hold 100 cm cube. But he just transferred 30 cm cube from the measuring cylinder to the beaker. So using a measuring cylinder, 30 cm cube of a distilled water is transferred into a into a beaker. Then he measured the initial temperature by using a thermometer. He placed a thermometer. The thermometer bulb should not touch the base of the container. It should be inside, but it should not touch the base of the container. The burette can be used here, but that is the next part. Usually they ask at the last, like which is more, what changes we should do. Even when an experiment is about the temperature change, instead of using a beaker, you should use a polystyrene cup, like, which does not allow the heat energy to escape. Then he add 1 gram of anhydrous lithium chloride. So a lithium chloride is added here. And he stir, and he water and lithium chloride mixture was continuously stirred using a thermometer, and temperature of a mixture was measured after 30 seconds. The beaker was then rinsed with water. He then rinsed this beaker with water, and then he did the second experiment using 1.5, the same experiment, but first 1, then 1.5, 2, 2.53, and 4 instead of 1 gram of lithium. Here, I think you have to complete. Just a minute, I will arrange. Yeah, maximum 6 are there. Yeah. So you have to complete these values. Write your answer. Yeah, 21.0. Good. 21.0, 21.0, 25. Actually, it's 25.5. Because it's like between 25 and 26, it's 25.5. And then the temperature difference, this is 4.5, 21.0, 21.5, 34.0, 32.5, 30.5, 20, I think it's 27.5. Yeah. 4.5 was there. This is not 25, this is 27.5. So 21 and 27, so this will be 6.5. Complete the last column for the temperature difference. Because then we have to plot a graph between the mass, um, and the temperature change. So this is 1, 1.5, 2, 2.5, 3, 2.53, and then 4 was there. And the temperature changes 4.5, 6.5, 9, 11, 12.5. I wrote 3 twice, so this was. and 12.5 and then 18. So these are the temperature changes. Usually the scale for specifically, like you have the scale in chemistry, you don't have to mark the axis. Usually it is labeled as well and the markings are there. Complete the table, complete a suitable scale on the y-axis to plot the result for experiment 1, 2. Temperature change. We have a minute, and they mentioned straight line through your points. The straight line must start from origin. So we have a minimum value 0, and we have a maximum value of 18. So if we select the scale, like if two boxes equals to 1, so this will be 1, 2, 3. So this will be 20. So each unit I took two boxes. 2 per 5 box. If I select 2 per 5 box, so as a result, what will happen? Yeah, but the thing is, when you select a scale, the number of the box should be like 1 unit equivalent to how many boxes. That should be the scale. Like if I select two boxes or 2 per 5 box, it means one box or one is like 2.5 boxes. That's a difficult thing. So here what happened? One box is two boxes representing 1 degree. The scale which I select, the two boxes are representing 1 degree. That this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, then 11, 12, 13, 14, 15, and so on. That's how we select the scale. Now we have to plot a graph, marking the points. Use thin lines to draw the graph. So 1 in 4.5. So when the mass is 1, the temperature change is 4.5. So this is 1. If I will write the number 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1 and 4.5. So this is 1, 2, 3, 4, and this will be 4.5. Then 1.5 and 6.5. So 1.5 and 6.5. This is already, so this will be 5. This will be 6 and 6.5. Then 2 and 9. So already this is 6.5, 7, 8, 9. So this will be 9. Then 2.5 and 11. This is already 9, then 10 and 11. And then 3 and 12.5. So already this is 11, 12, and then half box equals to 12.5. And then 4 and 18. So this was 12.13 now, 14, 15, 16, 17, and 18. So this was 4 and 12.5, so 13 here, then 14, 15, 16, 17, and 18. So these are the points which will appear. And now, as I mentioned, we have to start our line from origin, and we should draw a best width straight line for this. It must start, as I mentioned, we must start with origin or from origin. So when we start from origin, we want to draw a best width straight line. So to draw a best width straight line, I should have number of the points above and below approximately should be same. Like say in this one, I have 1 point above and 1 point below. And rest all of the points are lying on this line. So this is a best fit straight line. Is it clear this one?
Yes, sir, clear.
Then the next one, from your graph, deduce a temperature change when 3.2 grams of anhydrous lithium chloride is dissolved in 30 cm cube. So when 3.2, so what we'll do, we'll draw a line from 3.2. Like this is each box here is representing two boxes equals to 0.1. So this is 3.1. This you should always show this on your graph. So this is 3.1, this one is 3.2. So we'll draw a line from 3.2 and then find how much is the temperature change. So how much is this? Like 10, 11, 12, 13 and 13.5, about 13.5. So we'll say that the temperature change is about 13.5. So the temperature change according to the graph we'll write as 13.5. Estimate the temperature if experiment 6 was repeated using 60 cm cube. Look, if we increase the amount of the water, we keep all the things same, but we increase the amount of the water. Here, when we did the experiment 6, in experiment 6, what was the temperature change? The temperature change was 9. So if we double the volume of the liquid used, because more water particles are there, so what happened to a temperature change? That temperature change will become half. So like example, in experiment 6, the temperature change was 9 degrees. How much is the temperature? If we use 30 cm cube of a liquid, the temperature change was 9. If we have 60 cm cube, like double the volume of the water, water is not a reactant, water is absorbing energy from this reaction. So what will happen? The temperature change will become half, the temperature change will be 4.5. The temperature change, okay, if it was 18, if it was in experiment, it was 18, then it will become half of it, so it will become 9. If the temperature was 10, it will become 5. So whenever we double the amount of the water used for the experiment, the temperature change will also be half. So here answer, the temperature change will be half because the volume of the water is doubled. Yeah, water is not a reactant. It's here what happened. This salt